Hi AP Stat students. This video is going to cover information from section 6.3, and specifically we're going to focus on the first distribution covered in this chapter, which is the binomial distribution. So yesterday we talked about the basic characteristics of how we can identify a probability scenario as being one that's binomial. And so today we're going to dive more into the actual calculations to find those probabilities. So let's take a look at our first example. We're going to start with some review where we talk about whether or not a situation is a binomial probability distribution or not. And then from there, we'll get into the calculation operations. So let's read through this example here. It says, imagine that you're playing a carnival game to win a polar bear stuffed animal. The game requires that you hit a blown up balloon pinned against a board with a dart. You have a 20% chance of hitting the balloon correctly. If you throw 4 darts, what is the probability that you will hit exactly 3 balloons? So this is a kind of common carnival game where you'll see different balloons sort of pinned to a cardboard board or pinned to a bulletin board. And you take a dart and your goal is to puncture the balloon. And if the balloon punctures or a certain number can be punctured, then you can win a prize like a stuffed animal. So the first question that we want to ask ourselves is, does this meet the binomial distribution conditions? So there are a couple of things that we have to identify to know whether or not we can use the probability formulas that are associated with binomial probabilities. So what we want to check out is, when we're thinking about this, are there only 2 possible outcomes for each event? So here, our possible outcomes are going to be a success, and that's if you hit the balloon with the dart, or a failure if you miss the balloon. And so in this case, we do just have 2 possible outcomes. Either the balloon's punctured or it's not. Then what we want to ask ourselves is, are our trials independent? Which means, does each successive one not depend on what came before? So it doesn't matter if I've already punctured 1 balloon, it's still a completely fresh start when I go to try to hit the next one with a dart. So it is an independent situation. We do only have 2 outcomes. The next thing that we want to check is whether or not our probabilities stay the same, because remember that it's required that we have fixed probability values. So in order to have fixed probability values, our probability of successes, which is 20%, and failures need to stay the same. So fixed probability value, where P, the probability of success, is 20% or 0.2, which means our probability of failure, which we call Q, is going to be 80% or 0.8. So those conditions are met. The last thing that we need to check is, do we have a fixed number of trials? So that can't be something that varies. We can't decide we're going to do 2 things at one time and then decide we'll do 10 more. We have to know from the beginning, how many times are we going to perform this operation? So here it says we are throwing exactly 4 darts. So our n value is going to be 4. So we've met the conditions that we need to check. Is it binomial with just 2 outcomes? Is each event independent? Is the probability of success and failure going to stay fixed? And is the number of trials also fixed? Because all of those conditions are met, we're good to go to check out the probabilities using the formulas that we know for the binomial distribution. Before we get there though, we do want to be able to think about this situation manually. So this is the last time we'll have to think about a binomial distribution calculating things by hand. But we do want to make sure that we can identify sample spaces and figure out how to calculate discrete probabilities manually. So in this case, and in any binomial probability case, you have 2 possible outcomes to any situation, either a success or a failure. In this case, we are throwing darts at the balloons 4 different times. So that means there are 2 to the 4th, or 16 different possible outcomes or events. So what we want to do is to be able to write out all of the different possible outcomes. So the first thing that we want to think about is how is it possible that we can get 0 successes? So if we get 0 successes, that means that we have all failures. So if we think about that, that means we're missing the balloon every single time. So that looks like failure the first time, failure the second time, failure the third time, and failure the fourth time. So there's one event that's going to meet that condition. Then we want to think about what's the probability of getting one single success. So we have 0 successes, and then we've also got the probabilities of 1 success. So if you succeed the first time, that would be your 1 success. You're going to fail the remaining 3 times. You could fail the first time, succeed the second time, and then fail, and then fail. You could fail the first time and the second time, but succeed this time, the third time, and then fail the fourth time. Or the one other chance we can have where we only succeed once is to fail, 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 and then succeed. So there are 4 different possible outcomes where we have just 1 success. Then we want to think about, okay, we have instances for 2 successes, 3 successes, and 4 successes. So 2 successes, let's think through what that could possibly look like. If we have 2 successes, there are a few more different combinations for how we could get those in sequence of all of the different values. So if we look at our setup, we could have a failure, and then we could have 2 successes here. Or we could have a failure, a success, and a failure. We could have a failure, a success, a failure, and a success. Or we could have, let's see, what are some of our other combinations? Success, failure, success, failure. And then we can reverse some of these. So we can have a success, a failure, and a failure. Or we can have a success, a failure, and a success. So we have 6 different possible options where we could have only 2 successes. Then when it comes to 3 successes, we're going to have 4 different possible outcomes here of how that could happen. So we can have a success, a and a failure. We can have a success, a failure, success, failure, success. And then our last one, let's see, if we did the 3 successes first, we can also have the 3 successes last. So we have 4 different possible outcomes there. The last possible scenario, you guys, is where we'd have all 4 successes. That's going to be the least likely outcome here. But in this case, that would be success. So 1 possible outcome of that. So if we think through adding these back up, this 1 plus 4, 5 different outcomes, plus 6 is 11, plus 4 is 15, plus 1 is 16. So we've accounted for all possible outcomes. But our goal here was to identify what's the probability we will hit exactly 3. So we want to take our 3 successes and we want to add those probabilities up to see what the likelihood is that they would happen. Now, what we have to do for these, you guys, is each time we have 3 probabilities of success and 1 failure, our success rate is 20%. So we'll multiply 0.2 times 0.2 times 0.2. So 3 different successes and then 1 failure, 0.8. We need to multiply all of those together. So if you grab your calculator, you do 0.2 times 0.2 times 0.2 times 0.8. That value is going to be 0.0064. Now, because I have 4 different possible options of that happening, I can add that together 4 different times, or I can just multiply it by 4. So if I multiply that by 4, I've got 0.0256 as my answer. So that means the probability that I have exactly 3 successes, or that I hit 3 balloons if I throw 4 different darts, is going to be close to 3%, 2 or 3%. So not a great chance of getting 3 successes. Now, that's a lot of work to get one probability value, which is why we want to be able to use the binomial probability calculations to get there a little bit more quickly and a little bit more efficiently. So let's take a look at our third step, which asks how can we identify the probability outcomes using our calculator? So if we want to use our calculator, we get to use the binomial distribution formula, which is listed for us down here. So what this says, you guys, is the probability of, and then whatever number of successes you're interested in. So in this case, the number of successes is 3, because a success is defined as hitting a balloon, and we want to know when that happens 3 times. So what comes up next is this funky looking parentheses expression, which is really a combination expression, which is an operation that's used in combinatorics and probability work. But it can be defined easily as the factorial of the number of events that you do, that's your n, divided by n minus your number of successes, that factorial, times number of successes, factorial. Then this here is the probability of success raised to the number of successes, times the probability of failure raised to the number of events minus the number of successes. A lot of information, but let's just set this up for the scenario we just encountered. So the probability of 3 events, or 3 successes out of 4 events. So here, my n value is the number of trials. So that's going to be 4. And then I do 4 factorial divided by n minus x. So n is 4, x is 3. So that's going to be 1 factorial. X is the number of successes we want. So that's 3 factorial. So we're going to find that expression. Then we multiply it by probability of success, so 0.2, to the x value, so number of successes, which is 3, times our failure value, so 0.8, raised to the n minus x, so number of trials is 4, number of successes is 3, 4 minus 3, this is just going to be raised to the first power. So if you want to plug this into your calculator, you guys, what you want to do is to identify a factorial. The sequence that you want to follow in your calculator is math. And then when you hit math, you want to tab over to the probability, so PRB, it's the 4th different column. And then option number 4, there should be the factorial. So when I input 4 and then I go to math, probability, factorial, it gives me a value of 24. So that's this operation here. Then, if you just want to plug in, you can use parentheses to divide that value of 24 by 1, and then input your factorial, times 3, input your factorial, and if you close your parentheses there, that will end up giving you 24 divided by 6, or 4. So that's this whole term here is 4. And then I need to multiply by 0.2 cubed times 0.8 to the first power. So I'm going to multiply 4 by 0.2 cubed times 0.8 to the first power. And I get 0.0256, which is what we found in step 2, but that went by way faster. Now, the even better news, you guys, is that we can make it go by even faster than it just went by using one more technique in our calculator. So instead of having to enter 3 different factorial expressions, what I can do is use the combination button in my calculator. So my n value here, number of trials, is 4. I can use the NCR, which is the pick or the choose button, depending on which operation you're performing, and choose 3 successes. So what you want to do in your calculator, you guys, is hit the number 4, then go to your probability option. So from your math, go and find probability, and pick option number 3. So option number 3 should say NCR. Then go ahead and enter